So this is a video of inverse of equations and inverses of logs. To start off, we'll do the inverses of a regular equation. So you will place all x's with y's and all y's with x's. So it will look like x equals 3y plus 5 over 2y minus 1. To get rid of the fraction, you multiply 2y minus 1 to both sides to get 2xy minus x equals 3y plus 5. The 2y minus 1 cancel each other. To isolate the y, you add x to both sides and you subtract 3y to both sides to get 2xy minus 3y equals 5 plus x. Then you will take out a y and you'll get y times 2x minus 3 equals 5 plus x. To isolate the y, you will divide 2x minus 3 to both sides. Then you'll get the inverse of x to negative 1 power x equals 5 plus x over 2x minus 3. And that is the answer. When doing inverses, write the correct notation, which is the original function, with a negative 1 power between the letter and the x. If you write y equals, it will be incorrect. So I will do the rest of the equations and pause the video so you can do it on your own and you can check your answers. So now we'll move on to inverse of logs. Also, quick tip to remember to put all your y's to one side before you isolate the y, and remember your correct notation.
Okay, so now we're going to move on to inverse of logs, and you may have learned this in your Algebra 2 or Integrated 3 class, but a way to remember the transition between logs and a regular equation is log B for base, and then an A, that could stand for answer or whatever you want it to be, equals x, which can stand for x or exponent or whatever you'd like. And then that transitions by equaling B to the x equals A. So all of these letters are going to be the same things in your equation, and they just move places when you add the log. Okay, so for A, the first thing that we need to do, because we're doing inverses, is switch out the x's with y's and the y's with x's. So you get x equals 6 to the 2y minus 1 minus 3. Now we want to begin to isolate our y, so we're going to add 3 to both sides. Now, to get this y out of the exponent, we're going to use what we have up here. So since 6 is our base, that's going to be b when we do our log. The x plus 3 is going to become our a, and our 2y minus 1 is going to be our x. So we write it as log base 6 x plus 3 equals 2y minus 1. Now all we have to do is isolate this y. So you're going to add 1 to both sides and divide by 2 on both sides. So it becomes log base 6, x plus 3 in parentheses so that you know that the log is affecting everything in the parentheses. You're going to add 1, and since we can't have a 2 in the denominator, we're just going to multiply the whole thing by 1/2. And remember to put it in the correct notation, which is h to the negative 1 x. And that's your answer. I'm going to do the rest of these, and you guys can fast forward to see the answers. So now we're going to move on to the backside. Make sure to check your answers. The backside has a little bit of natural log, which might be new to you. Okay, so now we're moving on to some more inverses, except some of these are different because they have something called natural log. I'll explain that to you when we get there. So for letter A, we're going to start by swapping our x's with y's and y's with x's, just like with before. So we get x equals log base 7 4y minus 3. This acts just like the ones we had before when we said log base b a equals x and b to the x equals a. So what we do is we say 7 to the x equals 4y minus 3. Now you isolate the y like normal, and you get 7x plus 3 divided by 4 equals y, but instead we put it in our inverse notation, which is the g negative 1x. So b has something a little bit different. It says ln. This ln means natural log. ln is basically a fancy way of saying the log with a base of e. E can be found on your calculator, but we're just going to use it today as a symbol. So you're gonna swap out the x's with the y's and the y's with the x's just like normal by saying x equals, and then you swap out natural log base e of 2y plus 1. Now you do what you did before with the log base a equals x and the b to the x equals a, and you get e to the x equals 2y plus 1. Now we isolate y just like normal. E to the x minus 1 divided by 2 equals y in the notation j to the negative 1x. So basically, the e is acting just like any other base would, as if it were a number. If you substituted a 2 for it, it would do the same exact thing. Now we're going to move on to C and D, but I'm going to do these and you're going to check your answers afterwards. That's it for this video. Thank you for watching. Make sure to check your answers.